In December 2021, a rocket launched from the coast of French Guiana, carrying the most expensive scientific instrument ever built, a telescope with a mirror 6.5 meters across, coated in gold, folded like origami to fit inside the rocket fairing, designed to unfold in space and see further into the universe than anything humanity had ever attempted. The James Webb Space Telescope cost $10 billion and took 30 years to build. It was designed to answer specific questions about the early universe, about galaxy formation, about planetary atmospheres. It answered those questions, and then it found things nobody asked about. Things that broke models, things that rewrote textbooks, things that made physicists go quiet in a way that tells you the situation is serious. Let us start with the discovery that hit first and hit hardest. Within months of beginning science operations in 2022, Webb began imaging the early universe. The plan was straightforward. Look at galaxies that existed in the first billion years after the Big Bang. Measure their sizes, their masses, their brightness. Compare them to what the standard model of cosmology predicts. Confirm the model. Move on. The galaxies did not cooperate. What Webb found were galaxies that should not exist. Massive, structured, luminous galaxies, seen as they appeared just 500 to 700 million years after the Big Bang. Too big, too early. A galaxy that took our own Milky Way 13 billion years to build had apparently assembled itself in under a billion. The standard model predicts that galaxies in the early universe should be small, dim, and chaotic. Webb found the opposite. The reaction among cosmologists was not excitement, it was alarm. Bursts of star formation explain some of the mysterious brightness, but the problem did not go away entirely. Even after accounting for unusually efficient star formation, even after correcting for contamination from active black holes, there remained significantly more massive early galaxies than the standard model allows. Not enough to break the model entirely, enough to bend it. And then came the little red dots. Compact, intensely bright, red. They appeared throughout Webb's deep field images and did not fit any existing category. Some researchers proposed they were extremely compact galaxies with unusually efficient star formation. Others suggested they were black holes growing so rapidly that their radiation outshone everything around them. Then in September 2025, a study proposed something more radical. These objects may not be galaxies at all. They may be a whole new type of cosmic object. Something so massive and so dense that the boundary between a very large black hole and a very large star becomes unclear. A category that nobody predicted, nobody had a framework for. The little red dots remain unexplained. They may represent something genuinely new in our understanding of what exists in the universe, but the distance records kept falling. In January 2024, Webb observed a galaxy called JADES GSZ14D0 for almost 10 hours. When the spectrum was processed, the result was unambiguous. The galaxy existed just 290 million years after the Big Bang. The universe was less than 2% of its current age, and already there were galaxies large enough and bright enough for Webb to detect and characterize from 13.5 billion light-years away. The light reaching Webb's mirror from that galaxy left before the Earth existed, before the Sun existed, before the Milky Way had taken its current shape. And that galaxy was surprisingly bright, brighter than anything the standard model predicted for that epoch. We do not know why. This is where the Webb discoveries get genuinely unsettling, because the implications extend beyond galaxy formation to the fundamental parameters of cosmology itself. The Hubble tension, a discrepancy between two independent measurements of how fast the universe is expanding. One method produces a value of about 67 kilometers per second per megaparsec. The other produces about 73, an 8 to 9% gap. In a field where measurements are routinely precise to within 1%, this is enormous. Webb was supposed to settle it. The sharper resolution of Webb would reveal whether the discrepancy came from measurement errors in earlier Hubble data. It did not. Webb confirmed the tension is real. The universe is either expanding faster than the standard model allows, or something fundamental in our understanding of its early conditions is wrong. Webb did not solve this problem. It made it harder to dismiss. Now let us move closer to home. Saturn. In November 2024, Webb captured it in infrared, revealing the rings glowing with their own thermal warmth in a way no previous instrument had seen. 6 of Saturn's moons visible in a single frame, including Titan, its thick orange atmosphere lit up in the infrared with new chemical detail. Jupiter. Webb turned toward the Great Red Spot and found previously unseen features above it. Temperature structures, chemical gradients, wave patterns invisible to any visible light telescope, penetrating deep into layers of the Jovian atmosphere that had never been directly measured before. The pillars of creation. The famous cloud structures in the Eagle Nebula, first photographed by Hubble in 1995. Webb re-imaged them in 2022, and the result was not a sharper version of the same image. Webb's infrared cut through the dust and revealed hundreds of previously invisible protostars, young stars still embedded in their birth clouds. The image became one of the most widely shared scientific photographs in history. More importantly, it contained data on how stars actually form that no previous observation had been able to produce. Webb also found something unexpected about the earliest phases of the universe. Astronomers discovered that the early universe contained far more faint galaxies than anticipated, and those galaxies were emitting over 4 times the energetic photons scientists expected. This matters enormously. It suggests the light from these small early galaxies may have played a crucial role in ending the cosmic dark ages, the period after the Big Bang when the universe was filled with an opaque fog of hydrogen that blocked all light. Something ionized that fog and cleared it. Webb is now suggesting it was these tiny, numerous, intensely bright early galaxies, a discovery that reshapes our understanding of how the universe became transparent, and at the center of our own galaxy, something nobody expected. Astrophysicists used Webb to observe Sagittarius A star, the supermassive black hole at the heart of the Milky Way, for a total of 48 hours across 1 year. The result overturned the standard picture. Sagittarius A star is more active than anyone anticipated, constantly changing brightness, erratic flares, large bursts appearing without warning. Our galaxy's central black hole is not the quiet, dormant object it was assumed to be. It is restless, active, and the models built around the assumption of a quiet center need revision. Then came the exoplanets, and this is where Webb connects most directly to the oldest question in science. K2-18b, a planet 120 light-years from Earth, roughly 8 times Earth's mass, orbiting in the habitable zone of its star. In 2023, Webb analyzed its atmosphere and found carbon dioxide, methane, and water vapor. Then it found something else, a tentative signal for dimethyl sulfide. On Earth, dimethyl sulfide is produced almost exclusively by marine microorganisms. It is a biological byproduct. The detection is not confirmed. The signal sits at the edge of statistical significance. Multiple follow-up observations are needed. But the fact that Webb can even attempt this measurement on a planet 120 light-years away demonstrates that the tool works. The question is what it finds when pointed at the right targets. TRAPPIST-1. 7 rocky planets around a red dwarf 40 light-years away, 3 in the habitable zone. Webb studied TRAPPIST-1d and found it does not have an Earth-like atmosphere, not the answer anyone hoped for. But it proved the technique works for rocky, Earth-sized planets around nearby stars. The more promising planets in the system, TRAPPIST-1e and F, have not yet been fully studied. That data is coming. Alpha Centauri, the nearest star system to our own, just 4.24 light-years away. In 2025, astronomers using Webb found strong evidence of a giant planet orbiting a star in the Alpha Centauri triple system. If confirmed, the closest exoplanet ever detected, orbiting the nearest star, visible in the night sky to the naked eye. But 2025 brought something else first. Webb confirmed the source of a gamma-ray burst from a star that exploded when the universe was only 730 million years old. For the first time for such a remote event, Webb detected the host galaxy directly, a dying star, visible across 13 billion years of space, leaving a mark on the sky that only Webb could read. And in a separate discovery, Webb provided the first direct measurements of a moon-forming disk around an exoplanet, a gas giant called CT-Char b, 625 light-years away, surrounded by a carbon-rich disk that may one day become moons, the first time we have ever seen a moon system in the process of being built around another world. Also in 2025, Webb confirmed an actively growing supermassive black hole within a galaxy just 570 million years after the Big Bang, a black hole that should not yet exist. The standard models of black hole formation cannot produce objects this massive in this time frame. Webb keeps finding them. The problem keeps getting harder to ignore, and in August 2025, astronomers using Webb uncovered 300 unusually bright cosmic objects that may be some of the earliest galaxies ever formed. 300, each one a data point. Taken together, a pattern that keeps pointing in the same direction. Here is what ties all of this together. Webb was built to confirm and refine what we already believed, to fill in the gaps, to sharpen the picture. That is not what it is doing. It is finding things that do not fit. Galaxies too big, too early, black holes too massive, too soon, a potential biosignature on a world 120 light-years away, a restless black hole at our galaxy's center, a planet around the nearest star, a new category of cosmic object nobody predicted. This is not a failure of the telescope. It is the telescope doing exactly what the best scientific instruments do, pointing at the edges of what we understand and showing us clearly and repeatedly that the map is not the territory. Webb has at least a decade of observations ahead of it. Whatever it finds next, one thing is already clear. The universe it is showing us is stranger, richer, more complex, and more resistant to simple explanation than the universe we thought we were studying before it launched. That is not a problem to be solved. That is science working exactly as it should, pointing a better eye at the sky and seeing for the first time what was always there. If you enjoyed this video, consider subscribing. I will see you in the next one.